today we are going to be finishing up our foray into just talking about JavaScript outside of the context by talking about a couple of concepts that are going to be extremely useful to us once we start doing React. So, without further ado, let's dive into it. To quickly recap, just in case. To quickly recap, this is from the lecture yesterday, but it's supposed to end. Some of you guys might have missed it. This is how we represent a function in JavaScript. So we have here our input, which is the temperature in Celsius, and then the little arrow notation, and then the curly braces. And inside the curly braces is the body of the function. That's what? What?
For the live stream.
Okay, sorry. And this is the body of the function, which is what we want to do. So what this code is doing is it's blocking off a space in memory, which I'm representing with the gray box. And then it's going to store in memory this function. That is, I want to store it in memory somewhere that I have the ability to pick it up on temperature in Celsius and output it apparently. And we also talked about how in order to actually use this function, we need to assign it a name. Okay. And so we assign a name Celsius to Fahrenheit, which is just a variable that points to this location in memory where we stored the function. And the way that we do that in JavaScript is by having a variable called Celsius to Fahrenheit equals, and then this here, the highlighted part, is exactly the same as the function. So this function is just the value that we set our variable Celsius to Fahrenheit equal. All right, I'm to quickly review a couple concepts that will become important soon. This is about arrays. So we can define an array. Actually, we could use const here because we don't want this array to change. But we can initialize arrays like this and pop and push to remove and add things to the end of the array specifically, if all we care about is just adding and removing things from the end. And we can also loop through an array using this syntax, which basically is the same as for I in range length of pets that you might have seen in Python. And then here we are accessing the element of the pets array at index I. So if you want to reference those previous slides for this next part, I have the link to these slides at voclub.is/jscont. But real quick, I'm going to give you guys a minute to write a function that takes in an array of temperatures in Celsius and outputs an array of those converted to Fahrenheit. So in the previous slides, we saw one that just took one temperature and converted it to Fahrenheit. But now we want to take an array and do that for all of the elements in the array. And make sure that the input array does not change. So you're making a brand new array in your function. So I'm going to give you guys like 2 minutes to attempt this, and feel free to let me know if you have any questions. Give me a thumbs up if you're ready to move on. Okay, I'll give you guys like 30 more seconds. Okay, so I'm going to show the solution to this. Don't worry if you didn't get it all down. Okay, cool. Oh, that is not the right one. Okay, so basically what we have here, and I'll give you a little bit of time to parse this and copy it down later, so feel free to just follow along, is we take in our array as one input, and then we have the body of our function in here. And then the way that I'm doing it is I'm going to declare an empty array, and then as I go through my input array, I just keep adding to my return array. So I iterate through all of the elements of the input array in Celsius, and then I take the element and I do the calculation, and then I push or add that to the end of array F, which is what I'm constructing as I go. And then that's going to be the array that I return. Another way to do this is you could copy the input array. So if I were to do this, I could set this to be equal to a copy of the input array. And then as opposed to pushing, I could just say array F at index I is equal to this. And so then I would just initially fill out my array with the input and then just update it as I go. Does anyone have any questions about the code here? Yes. Difference between what? Oh, of course. So basically, here we use const, or the reason why I use const is because I don't want this to change. So if I have an array that stored somewhere in memory, and there's certain elements, and then I have my, what do I call it, array F. And I'm having it point to that location in memory. Since it's const, this cannot change. So this will always point to that location in memory. And I can update this array, I can change it, but this will always point to that location in memory. Whereas let, if I, for example, when I use let I in the loop, then I have I pointing to this integer, which starts out as 0. But the thing is, since I'm going through the loop, I want to reassign I to be something different every time. And so I want I to be able to change to point to 1, and then to point to 2, et cetera, et cetera. Does that answer your question? Okay. Any other questions before we move on? Okay, solid. And I will comment all of this out. And then go back. All right, so now let's say we want to do some other stuff. In addition, maybe I'm doing a bunch of data processing with regard to temperature. And so instead of just converting Celsius to Fahrenheit, I want to convert back from Fahrenheit to Celsius. And I also want to be able to convert from Celsius to Kelvin. So if I were to write 3 functions for this, what would be the really wonky way of doing this? Anyone? I'll give you a hint, it involves duplicating code. Yeah, in the back. Yes, so we could write a different loop for every single one. Basically taking the function that we just wrote, that's the function we just wrote, and copying and pasting this 2 more times and only changing this part in order. Now that would be kind of bad because reusing code is bad for many reasons, one of which is like if we had a bug like this said less than or equal to instead of less than, then we would have to change that in 3 places of the code. That would be very sad. And so ideally we want to be able to take all of this code, like the whole array logic and the loop and everything, and reuse it, and only not reuse the part highlighted or like the part that's grayed out there. So that's the only part that's different across them. So we want to reuse the rest of it. And so hence we use callback functions. So what we're going to do next is we're going to write a general function called modify array that does everything except that part that I highlighted before. So it takes in the array that we want to transform, and then a callback function that we'll use to transform the array. So what do we want modify array to do exactly? So this is an example of a signature. The parameters are like I just described. And let's say we call modify array on this array of cats. And so the parameters that we give it, the array is this array of cats, and the transform function is a function that takes in one singular cat, sends it through the function, and it outputs one cat of the hat. So this transform function will take in one element of the input array and output one element of the array that we want. And so what we want modify array to do is we want it to send each individual cat in our input array through the hatify function and add it to the output array that we're constructing. So next, I'm going to task you guys with writing that. So write the modify array function, and then you probably won't have time for all of these, but just use your modify array function to first convert an array of Celsius temps to Fahrenheit, and then convert Fahrenheit to Celsius, and then maybe if you have time, Celsius to Kelvin. So I'm going to give you guys around 4 minutes, and please ask questions. Oh, I forgot to update the slides, but the formula for Celsius to Fahrenheit is right here in the example code, and this is the example code for the code for the previous thing that we did. If you're unsure how you would do this, I highly recommend turning and talking to someone near you. This is a sense for where the room is at. Can you raise your hand if you have a sense for what you should do and are doing it? And can you raise your hand if you're pretty lost? Okay, cool. If you're pretty lost, please hop on the help queue and we can get someone to help you with it. Can you raise your hand if you successfully coded the modify array function and maybe one of these bullet points? Okay, cool. I will give everyone else a little bit more time. All right, I'm going to pull us back together. No worries if you were not able to finish. Oh wait, that is not what I wanted to do. I just wanted to stay on the slide. Okay, so on the left-hand side here, we have our old function that we wrote at the beginning. And then on the right-hand side, we have modify array. And notice the only things that are changed are what is highlighted in blue. So we have, instead of one parameter, we have two. Now we take in this callback function, transform func. And then as opposed to taking the element of our input array and doing a hard-coded calculation, now we just take the element of our input array and send it through our callback function, transform func, and then that's what we add onto our output array that we're constructing. And then if we were to actually use this to convert Celsius to Fahrenheit, then we would do the following. So we define our function, C to F, that converts something in Celsius to Fahrenheit. And then we can call a modify array using our input array, and then also the C to F function. Does anyone have any questions on this code? All right, cool. So I'm going to actually diagram out what's going on in this code. And this is very similar to the diagrams that you have seen or will see or might not see in 6101 or 6009. But basically, I'm going to diagram out sort of like the program where all the variables live on the left side. And then on the right side, we are going to have where our data is stored. So this is like memory. So we have here our, what we would call in Python the global frame, but just like our general program execution space. And then here on line 1, we're defining a variable called modify array. We define modify array, and then we make that point to our function, which is stored in memory. So somewhere in memory, we have this function that takes in 2 parameters. I'm going to write them in orange. Array and transform function. And then we do stuff with it. I'm not going to write all that. Okay. And then on line 8, we define another function or another variable called C to F. That's going to point to the location in memory where we store this other function. And this other function takes in kind of as a parameter. And then it's going to do stuff with it. It's going to output those temperature Fahrenheit. So we have these 2 variables. And then we're also going to define another variable on line 11. That's temp C. And that's going to point to an array. So this is our array, 0, 25. Okay. So what happens on line 12 when we call modify array? So what's going to happen is we're going to make another little program execution space. And the reason we draw this in a separate box is because basically within the function, we have different names that we're assigning to case. Case in point. So this is going to be represent the call to modify array. And that's going to be with temp C and C to F. Sorry if that's not very legible. And then here, we're going to set the names array and transform function to be equal to the parameters that we passed in. So here, if you see on line 1, we named our parameter array, but then on line 12, we passed in temp C. So now array is just going to point to whatever temp C was pointing to. And then transform function is going to point to whatever C to F was pointing to. So we look at C to F, we see it's pointing to this in memory. And so this guy also gets a pointer to this same block of memory. So this, does anyone have any questions? Are y'all following? Can I get a thumbs up if you're following this diagram? Solid. Okay. And so now within this function, like we have access to our temp C function and our array from our main program execution space, and we also have it in this function body. So then the function uses array and transform function to do all the stuff that it needs to. Cool. And I'm going to come back to that diagram later. Well, psych, modify array was already written for us. So there's, as you might expect, changing all the elements of an array based on a certain thing that you want to do with it. It's pretty common, and so JavaScript authors have written it, and it's called map. And the only difference between modify array and map is that in modify array, we took 2 parameters, so the array and the function. But in map, we have the array and then dot, and then map, and then just 1 parameter, that's the function. Oh, another thing that I forgot to mention. I forgot to mention this on my driver too. So we have Okay, here. So if I have C to F, oh my gosh, I forgot to undo it. That's so sad. So this is what we previously had. And we took the name C to F and we plugged it into our modify array function. However, we could just take this function and instead of assigning it to a name and then sticking that name in the function, we could just stick the function in there. So this is entirely analogous to what we had before. The other thing we can do to make this code even shorter is if we just have a function with one line and one return statement, like that's all we're doing in the function, then we can just yeet the return statement. Then it's implicit. And get rid of the curly braces and just have parentheses. So instead of saying temp C is arrow sign, curly braces return this, then we have this implicit return statement where we just take the input, the arrow, and then the output, and no curly braces needed. So this is very handy when we're doing stuff with map. Okay. Now we are ready to go back to this slide and look at this example for map. Does anyone have any questions on this example before we move on? Solid. Okay, I'm going to ask you guys to copy down this array of rectangles and notice that it's an array of JavaScript objects where each object has a width and a height. And then use that to create an array of the areas of the rectangles. I'm gonna give you like a minute and a half or so to do that, and let me know if you have any questions. Raise your hand if you're ready to move on. Okay, I'll give it a little more time. All right, cool. I'm going to pull us back together. No worries if you can finish. And nope. Okay. Okay, so we have our rectangles right here. And then ignore that. In order to, the function that we want to write maps a rectangle, which is one of these JavaScript objects, to its area. So its width times its height. And so if we have a rectangle object like this, then what we can do is we can take the width with rectangle.width and the height, multiply them together, and then that's what we get out. And we can also rewrite this code not using the curly braces. So just like this with the implicit return statement. So we're just mapping input to output. And then if you copy and paste this into your browser console, you would see that you can get out an array of the areas. Any questions on this? Give me a thumbs up if you feel like you know what's going on in this code. Yay, okay, that looks pretty good. So next up, we have another important JavaScript array method thing, and that is filter. So it takes in an array, or like we have an array.filter, and then we take in a callback function. So this time the callback function doesn't map an element of the input array to like an element that we want in our output array. But this time it maps an element of our input array to a Boolean, to true or false. So in this example, it'll take every element of the array values, send it through this callback function, which returns true if it's greater than 0 and false if it's not. And if that callback function outputs true, then it'll take the array and put it in our output. And if that callback function outputs false, then it will not put it in our output. So we're filtering out the elements that don't pass this callback function test out of our array. And then in this example, maybe I just really don't like Kenny for some reason, and I want to filter out Kenny out of my names array. So let's do some practice with this using the same rectangles array. Use filter to create an array that only contains rectangles with perimeter greater than 10. I'll give you like a minute for that. Thumbs up if you're ready to move on. Okay. Not everyone is done, but I think for the sake of time, I'm gonna go over it. So here, what we want to do is we want to take our rectangle and get its perimeter, and then check if its perimeter is greater than or equal to, or greater than 10. So here, I'm going to uncomment this. And so if we have a rectangle, then we are going to want to get its perimeter by taking the width times 2 and the height times 2, and then checking if it's greater than 10. So this will be true if the perimeter is greater than 10 and false if it's not. And that's this function maps the rectangle to this Boolean. Any questions on this? Okay, cool. Okay, so to recap, this is what function syntax looks like. You have the parameters and then the arrow and then the curly braces or just inputs and outputs. And the reason why I'm driving this home aggressively, even though you've seen it so many times, is because pretty soon you're going to see functions as callbacks in a lot of different places. And so it's important to recognize like when things are functions. So these are two examples that we did of defining functions. And so why and when are we going to use functions as callbacks? So we just saw examples of where it's nice for code reusability. So with map and filter, we don't want to have to move through an array and like write that code so many different times. So callback functions make our code more generalizable. So that's great. The other reason why we sometimes want to use callback functions is for abstraction. That is, say I want to have something where when something happens, I do something. Basically, what callback functions allow us to do is write the code for do something without having to write the code for the when this happens, which I will go into examples of, and so you'll see in a bit. So let's say that we wrote a function called update animation, and we want to call it every 10 milliseconds. Now, we could write the code ourselves that interfaces with timers, but that seems very overly complicated because then we have to like interface with the computer's clock, or like I don't even know exactly how that works. But the point is, we don't want to do that, and so the JavaScript authors have already done it for us. So this code, set interval, which we saw in the workshop earlier, just calls update animation every time that the timer fires, every 10 milliseconds. And that's nice, because the way the timer goes off is managed by whoever wrote the set interval code, the JavaScript authors. And all we care about is the update animation part. And so remember earlier, when we had our frame, like where we were writing our code, like our main frame, and then we had the function. Well, it's kind of similar, where we can have our code. And then here we have pointers to, like we might have a pointer to update animation. And then that's stored somewhere in memory. And it'll do something. And then what we can do is we can call set interval. I'll just write it here. I'm not going to have a name for it. But if we have our call to set interval, if we give update animation as a callback to set interval, then now set interval, I don't know what they call it, but it has a pointer to our update animation function. And so now that set interval has a callback, a pointer to our update animation function, they can call it however often they want, whenever they want. And this is not our code. This is black box. We don't need to know what goes on in here. So that's very convenient. And there's a lot of other places where you'll see similar logic throughout the rest of the course. So earlier in the snake workshop, we wanted to respond to keyboard inputs. So we wanted to say, okay, when you get a key track, we want to do this. We want to change the snake direction. But we don't really want to bother writing code to interface with the keyboard or with the browser who gives us the keystrokes, and like filter the events to check whether it's a keystroke or like mouse click or drag or like what key it is, all that stuff. And so they simplify it for us. When we say, okay, we want, when you get a key down event, then do this. And the do this is the callback function, the highlighted part that we wrote. Next up are a couple examples that you will see later on in WebLab. You don't have to fully understand what's going on here, but I want to show you so that when you see them, you recognize that these are callback functions. And the one thing I want you all to remember about callback functions is anytime you see a function as the parameter to another function, anytime you see a callback, ask yourself, who is calling this function and why are we passing it as a callback? So in this case, comment.find is basically a database query. And so that asks the database, please get me all of the comments. And so that returns, this evaluates to a JavaScript promise, which is something we'll learn about later. And that promise resolves as soon as we actually get back the information from the database, which could take a while because it's going over the internet. And so the .then basically says, when that promise resolves, then do this. Take the comments that we got back and send them to the front end and do stuff with them. Okay. And then that code that we just saw is going to be, wait, actually, I want to back up. So who is calling this callback function? The JavaScript library code for .then is calling that function because the .then knows like when the promise resolves. And that was actually wrapped in another callback function. And that callback function is for our router. And so when we get a request to the /comment API endpoint, then we do this, all the stuff that we just talked about. And so the reason why this is in a callback function is because we want to do this whenever we get a request to this endpoint, but we don't want to write the code that like interfaces with the computer ports and like listens across the network to see when requests are coming in. Router does that for us. And so we just tell it, when you get a request, do this. And another thing we'll see, this is not a callback function. In a callback function, we give the function as a parameter to another function. But here, we're actually getting a function as a return value from another function. So this useState function, what it does is it takes in the initial value that we want for our for a state variable for React. And then what that does is we get back exists, which is our variable. So we have a variable const exists that is set to the false initial value that we put into useState. And then we get set exists, which is a function. So now we have a function that we can use to update the state. And the question of, well, who's calling this function? We're calling the function. And why is it a callback function? You can think about that later on this week when we see this again. But I just want to pop it up here to get you guys thinking about when we're passing around functions and what all of that means. So that is all that I had for this lecture. And now we are going to dive into React, which is all of the stuff that this was sort of priming you for.